Hey, everybody. I guess we are live. Thanks a lot for joining tonight for another session of GDG Nuremberg in collaboration with Women Tech Makers Nuremberg today or tonight. And that's actually the first thing after thanking you all for joining to do. I would like to call Denise for thank Denise for helping us out for the session tonight. And I would also like to make you maybe introduce women tech makers to those amongst us who don't know what women tech makers really means, or yeah. So yeah.
Okay,
Go for it.
Thank you. So hello everyone, happy to be here. I am Denise Cepeda, product designer in digital health, and I am the organizer of Women Tech Makers Nuremberg. Women Tech Makers is Google's global program providing visibility, community resources for underrepresented groups in technology. The goal of Women Tech Makers Nuremberg is to promote diversity, inclusion, and equity in STEAM. And we enable meaningful events as this one for professional and personal growth. Our policy of conduct is to be excellent to each other when we express our opinions. And I am very happy for this event and very happy and very grateful for the speakers and also to Nino and Lucas that are enabling this event. And I hope that all of us have a lot of joy and of fun and learning. Thank you.
Yeah, thanks you. I'm pretty sure we have a lot of fun because we have great speakers tonight. We have Enrique, we have Karin, we have Nick. So yeah, happy to have you all there. Considering our time constraints, let's move forward. And so I'd like to introduce you to Enrique, our first speaker. Enrique has already been here before Corona, before the COVID pandemic, in person to give a talk at GDG Nuremberg. So, but for all those who don't know Enrique, I'd like to introduce him very shortly. So Enrique is what I would call expert on multiple levels, actually, because you're an Google developer expert for Kotlin, you're a Google developer expert for Android. As far as I know, and you are a writer as well, because last time you were here, you presented, or you had just finished writing your book on the developer community, which is a great read, by the way. And you are more or less also an expert in running. Is that true, Enrique?
Well, you know what they say, jack of all trades, master of none. So I don't know if I qualify for being an expert on running, but yeah, I ran quite a bit. Last year, actually, I got injured in June and July, and I had to stop and decrease for a little bit. But 2 years ago, I ran 5,000 kilometers in 1 year, which is a reasonable amount, and yeah, a few marathons and ultra marathons. And I hope this year things get back to normal and I can keep running, because Corona is also not the best situation for marathon runners and ultra runners and etc.
Yeah, great. And I mean, it's a perfect transition to your talk, actually. You might not really think about it already, but if you take the word running and you strip it to the root, you take to run, and you translate it to Latin, it brings you to curare. And curare, again, is the base word for concurrency, I'd say. And this is actually your talk, something your talk will be about today, right? It's about Kotlin Coroutines for JVM. And it's, yeah, makes us handle concurrency pretty easy in the Kotlin world. So go for it. Tell us about what's so great about Kotlin Coroutines.
Let me share my screen here. I actually never thought of this correre in Latin being the, you know, my native language is Spanish, so I understand probably correre better than laufen. Okay, so can you see my screen, Nino?
No. Yes.
Okay, so I have
Okay.
Okay, good. So now you see my screen and myself. So I'm gonna.
Yeah, perfect.
Now it's good, right?
It's good. I can see everything.
Great,
So
fantastic.
Should work.
Great. So my name is Enrique, as Nino introduced me, and my talk is about diving into the coroutines for Android or the JVM. Super shortly about me, I'm a Google developer expert. This is my Twitter account, and I mostly do Android and Kotlin for backend as well. But I've been doing a few things in the past as a freelancer. So coroutines, now they become very popular lately since JetBrains introduced them in Kotlin, and I think for many of us we could think like, oh, this is like a new concept that is coming now, and it's not really true. Coroutines have been for a while in the computing world, and they exist for many other programming languages. So this is the definition as it is found on the Wikipedia, and it's they actually have implementation for. So as Android developers, let's think on this piece of code. We want to. This is very common, or a variant of this code can be very common. We have some user data that we want to fetch, and we want to play it put it on the screen. Normally, if the conference is offline, I ask, can you think about a problem in this code? Do a dramatic pause and see if anybody wants to write it. But since we're doing it online, I'll just give you 5 seconds to think about it. So in Android, we get if we execute this, the network on main thread exception, because we cannot execute network request on the main thread. So what if we do this? We put it inside a thread. A few seconds more for you to think about it. We get this has been called from another thread, blah, 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 exception, because we can't update the UI from a different thread. So then we could say, well, let's going to use a callback. We'll just fetch the user data, and when things are ready, then we came back to where we were. Then we start leaking the callbacks all the time, because we make the request, we close the fragment or activity, and then the request is coming, the activity doesn't exist anymore, but the reference is hold, and that's very bad for the app. So then we also end up with this sort of a screen, because we need to concatenate some callbacks with another callbacks, and it's pretty much unmaintainable. This is called callback hell, and if you Google it, you end up in a page that's a website that tells you why you should not be doing this. Well, we could be having these subscriptions where we execute a request, we store the result on a subscription, and then when we need to stop or pause or leave our screen, we cancel them. This also deals to this sort of problem. Of course, we could use composite objects or composite subscriptions. That means that we have all the subscription in a composable one, but that we start making the thing more complex. I put this as a joke. It's 2021, so you should not be using this. But well, before in the past we have the asyntas that were solving this problem. We could do things in background and then pre-execute and post-execute. We have RxJava. RxJava is a big library for Java that allows us to solve this problem. As here you can see that we will be calling the fetch user function that will be returning an observable with a generic of type user. And essentially underneath this is sort of could be like the callbacks we've been displaying before. We need to specify where this is going to be running, where is this going to be observed, etc. We have live data from Google, and similar to the RxJava, in live data, we have the function fetch user that is returning a live data object with generic user, and we just start observing of the function on the function, and when anything happens, we just update our text view. So, like always, we have each company have their own solution. So far we have live data. It uses observable data holders. We have RxJava that uses a combination of observable, schedulers, and observers. And we have coroutines that are using suspendable computation. So why one more? Well, live data is not really fully complete, only supports the main thread. And RxJava is complete, but it's very easy to misuse. It feels like an overkill. We have so many things that we don't we're probably never going to use in RxJava, and the learning curve is a step. You can't start doing RxJava from the minute zero. You can do it either with coroutines, but the learning curve is not as a step as with RxJava. So coroutines are simplified, comprehensive, and robust. Of course, every software developer says, my software is simplified, comprehensive, and robust. So let's try to argue why this is true. They also have now first-class support from Google in Jetpack. So Google is officially recommending you to use coroutines, which that might be significant if that, well, they're moving into this direction in the future, and we want to maintain software for a number of years. In a nutshell, let's see what we have so far. Coroutines simplify the async code by replacing callbacks. Let's take a look at this blocking section of code here. So we have a function load user that calls an API to get the user, and then it displays it on the screen. So how this is working on our Android app? We call the function fetch user. This essentially keeps the thread lock. So all the onDraw methods, when they're trying to update the screen, are not working. And when the result is ready, we display it on the screen. This onDraw method is the one in charge of updating the screen, changing colors. If it stays for more than 10 seconds, we get an ANR, automate application not responding, and that's very ugly. So coroutine. We came back to the block of code here, and we call the function so user that updates a text view or something on the screen. Here we will be calling fetch user. We keep drawing the screen, and when it's ready, bam, we just display it. Now, coroutines are very similar. See that we're essentially replacing that callback with this suspend keyword. It's not much more different than that. How they work is, we suspend the function, we start executing what we call a coroutine, and then we resume when that's ready. Suspend and resume are replacing the callbacks. So what we have as the function suspend load data that returns some data, internally it compiles into something like having a continuation object with a generic of type data. The continuation object essentially is the object in charge of calling the resume when the data has been fetched. If you're interested into this, I think you might not see this because I'm sharing my screen, but you can Google for deep diving into the coroutines by Roman Elizarov in the Kotlin Conf 2017, and he goes so much into the details of this continuation object. Again, back to our example. So we have the thing. The coroutines example is using a suspend function. The asynchronous one is using a callback. Now, let's analyze the suspend keyword over here. So yeah, exactly. So in the we are here specifying in this example from here in which context do we want to run this. This is particularly important for Android because some operations we want to execute them on one thread. We want to execute them on the main thread if we need to update the screen, and we need to combine them somehow, right? Like we get some data from the network or from a database, and then we present it on the screen. That's why we're going to be using dispatchers. In this case, we can see that we can say the function fetch user, it's equal to the function with context, specifying this dispatcher, and then inside we will have our IO operation. We have three dispatchers: default, IO, and main. Default is the CPU one, is the one that should be used for operations that are very intense in terms of computation. Think of doing processing in any image or storing some sort of data locally. IO for network and disk operation, and main is the main thread on Android. So back to the example. So we have the function with the context IO. We put up our blocking calls inside this with context function from here. And let's see how it works under the hood. So we have the stack for a program or for a thread, the main thread stack, where we store our methods, our variables, all the information that we're having, etc. So when we can hear and the compiler says, oh, we have a suspend function, we put a marker on the main thread stack. Everything above will be a coroutine, and underneath will be a regular function. We keep moving. Then we see like, oh, then this suspend function is called load user, and it's calling another fetch user function that is a coroutine. So we put them aside and start executing them. while the rest of the app keeps moving forward. And then at some point, this fetch user gets the information from the backend and tell us, hey, I've downloaded this user. This is the information I have. Then we resume the execution. We take the data from fetch user, consume it. Then we consume as well the function load user, and that's the way we go. Summarizing until now, coroutines replace callback, and they provide main thread safety. Very important for Android developers, right? The building blocks we have seen so far the with context function. It returns a result. If there is an exception, it's uncut and the application crashes. But we also have launch and async. Launch is a operation of type fire and forget. We just start it and bye-bye, do whatever you have to do. Of course, also crashes if there is, we are not dealing with the exception. Async returns an unknown block in future on a deferred object. And here we can get also the exception if it happens. And well, we also have a few contexts that we'll see later how to use them. We have a UI context. This dispatches the execution into the Android main thread. We have the common pool, which dispatches the execution into the Android background, and unconfined, which goes into the current thread. Let's see launch. And let's see this context we've seen before, the context. And this is a more extended example as the one we saw before. We want to load some data. So we saw a loading indicator. We fetch our data somewhere, so the data hide the loading indicator. So now we will be calling, see that this function is equal to launching this thing on the UI context, right? And if we want to, so we want to update on the UI context, right? But the result needs to come from the background context. So this is how it would be properly done with a coroutine. Data provider is providing the data in the background context, and then everything gets updated on the UI context. So we can do a lot of things also. So this is a very basic example, but we can combine tasks, we can launch it in different order, etc. So same operation. Let's see how we can choose tasks sequentially. That means one after the other. In this case, we will have the result one calling to this with context, and one function result two, and one will be executed after another one. We can also run them in parallel. See that here we are calling the async function. This is the relevant part of code. And what we do here is calling the function await to each of those tasks, and that executes both tasks at the same time. Of course, we can also have a create a variable here as a list, and then call the function await all, and it will start all the coroutines that have been stored in this list. We can run them with timeout if we have a backend operation that's always very meaningful and helpful. So we have this function with timeout or null. If no object is provided, we will just return null, and we need to handle the null. Cancellation. One interesting thing with coroutines is that they, and of course it's very necessary, they provide a mechanism to cancel the coroutines. If, for example, we're leaving the screen, the application is being closed, etc. The principle is very easy. We have this load data function that launches and does something. We could have a job object. Every time we click, the job is equal to this function. And when we do on back click or on stop or whatever we need to do, then we just cancel the job. This cancels the coroutine. It's interesting because if we see the what a job is and what can we see in a job, we can see if it's active, if it has been canceled, it's complete. If it has children, we can invoke something on completion. So it's a very complete solution. Error handling. How can we handle error? Well, we can do some try catch. That's the old style. We just try to do something. If something happens, then we catch the error and print on the screen. We can store inside a deferred object. So see this example when we're calling the async and we try to present the result. We could have load data assigned to a bar of time deferred and invoke on completion. If something happens, then we get the throwable object and then we can deal with it. We can use a coroutine exception handler. see that in this case, the relevant part is the load data. When we're launching, we're specifying the context and the exception handler. In this exception handler, we can just handle the exception as we wish. Then there are a few other strategies that you will see if you check some tutorials and code examples from Google. We can return null if there has been an exception. So if we're trying to get something and we get null, then oh, good, then that's going to print an exception. I don't think that's the best one, but you'll see it sometimes. So here you will see if the result is null, then it has been, I imply it has been success. Sorry, if the result is not null, I imply it has been success. Otherwise, it's been a failure. We can return type T. So for example, here we have this class result that contains either a success with a generic or the exception as a failure. There is a strategy also doing this with seal classes. You know, a seal class in Kotlin is a enum with superpowers, and you can essentially have a seal result class that contains either the result as a success or failure, and then you can iterate over both of them. So in this case, it's something like if success is different of null, then we have the data there. Typically, if we're making a network connection, that will be the network request, our DTOs, etc. Otherwise, we have the exception. Testing, we need to test of course, our coroutines, and it's possible to test them. Let's think of a presenter. So this main presenter, for example. We can use our testing framework. We can use Mockito if we're developing for Android, and see that in this case, the main presenter is receiving unconfined as the background, the context from the coroutines. We just proceed to test our load data function, and then we can use verify, Mockito, and see that things are happening. Is this replacing RxJava? Here I also make a couple of seconds of silence to let people think about this. Well, the answer is it depends. There are a few things that are analog in RxJava and coroutines. For instance, subscribe on would be the initial context, observe on would be the with context that we have seen, disposable are more or less jobs. I think RxJava have, there are a few other considerations that we'll see later. I would say by now that they are not that direct. They can replace part of the functionality, but well, RxJava have other things, and there are other considerations that are more important. A few more things. So retrofit 2, I think that the version 2.75, I think. Well, before we could do something like that. Like we could have a retrofit function that gets something on a deferred object, and since one of the latest versions, retrofit has support for coroutines, so we just need to specify the suspend keyword at the beginning, and bam, we already have a coroutine. Room also has support for coroutines. We just need to specify suspend at the beginning, and we are running our room queries with coroutines already. They have support for transactions. So if you see this transaction over here, we can also create it as suspend. And inside there is one function that is a coroutine, one other that is not a coroutine. So we can combine them as we wish. And then if we have this clear data function from here, which is a coroutine, we could be calling transactions, etc. So it's essentially plugging coroutines in Room. It works out of the box. Okay, so let me hide this. Please and hide the. This thing from here. No, I think. Okay. So Room. If we want to test Room, there is this run blocking function that is everywhere in the documentation, and we should be using. So run blocking is a function that essentially blocks as it is running, and it blocks the current thread until it's complete. It makes sense for tests, probably doesn't make sense to use it in the real world. Some serving. I found this somewhere in Twitter. I think like 6 months ago, I could not trace the original source, but that was back in time. Like 40% of the people wanted to use coroutines. Around 24% of people use them in sample projects, or 12 in sample projects and 12 in production. An astonishing 12% of the people didn't know what coroutines are, and 24 don't want to use coroutines. This is important to know because it will be depending on other projects, likely on open source frameworks, and it seems that right now does not seem to be the majority option. It will take some time until it gets there, but it's very likely to get there since now has an official Google recommendation. What you should be doing. So if it's a greenfield project, you should probably give them a try. As mentioned, Google is going now Kotlin first, coroutine first, they get a priority. Documentation is also written in Kotlin, so it seems like the right approach to use at the moment. The important considerations and the ones in the real world. Do they suit you? Do you have a team that can do this? Can you apply refactoring if your code is, you have a big code base? Do you have time? Should you start with small sections, or your code is so entangled that it is impossible? For me, those are the real important questions in a real world project. We can't just keep in most of the projects the latest state of the art. So those considerations are very personal as well. You need to answer them for yourself and see if you're ready to go with them, or you can start doing that step by step. A few other resources. There is this coroutine guide from here. It's the official coroutine guide from Kotlin, so they have a few nice examples on how to start using them, etc. Never forget that they're open source, so you can literally see how they're implemented. So if you Google for Kotlin X coroutines on GitHub, you'll see the repository. Kotlin Slack, if you're not there, is an Slack from JetBrains, where you have people from JetBrains working, and they're very friendly, and they can answer your questions. If you allow me some spam here, this is a mailing list that I curate. I send them every Sunday. I think it's a fantastic way to stay curated, because you essentially get one day like a summary of things that are going on, and as you can imagine, there are many articles and open source repositories, etc., being written now with coroutines. This code lab from here, it's from Google, and they show you how to use coroutines from the Android perspective. So if you're an Android developer, it's very interesting. There is also this repository over here, Android Architecture Blueprints. It's a repository from Google where they curate different architectural approaches or nice practices when you have to develop Android apps. And now they have how to use Kotlin coroutines for background operations. So if you download it, you'll see how a real Android app should be using the coroutines under Google suggestions. So it's definitely a good place to check. This post from here is a bit old, migrating RxJava to Kotlin Coroutines, but I think it has gotten old better than the milk. So if you check it out, they will, Chris gives you some nice tips on which operators should you start migrating, where should you start, how some of the functions in RxJava equiparate to the ones in the Kotlin coroutines, and how should you start moving from one to the others. So I think this is a fantastic place to also start checking if you're using RxJava. So, oops, I didn't update the, now we have Kotlin 1.4 and almost 1.5. So don't block, keep moving. I think you got something interesting from this talk, and if you learned something new, I will be very happy about it. If you have any question and I happen to know the answers, I will be super happy to help you. Otherwise, thanks for being here, and I hope you enjoy the other talks. I'm sure you will.
Hey, thanks a lot for this talk. We have at least 2 questions. The first one is, isn't with context the same as async await from done none?
No, I don't think so. With context specify with context specify the context when the coroutine will be running, and await start executing them with the context that has been previously specified. Two different purposes. Hello, Nyam, by the way.
Okay, thanks. And Ashwin Kumar asked, testing coroutines is always hard. Are there any strategies that you use? I mean, you already talked about testing. Is it still, yeah, but are there any strategies you use personally? Any more tips about it?
Not really. I've been writing tests for, as mentioned in the talk, for Room. And it's essentially, the only thing is this unconfined that I think is not super clear. Why should you should be using this one? But it's actually in the examples from Google. You should not be specifying the for test the background or the UI one. Other than that, I think they actually, if you're testing coroutines that are integrated with some framework, I think they work relatively out of the box. But no, I think that would be one of the tips. The other one is using this run blocking function when you are testing, for example, Room or some operations for tests might be more helpful than other ones.
Okay, then we have another question. Could you show the slides with the resources again, please?
The one from
yeah, your last slides.
Will be the slides. Yeah, should I send them to you, Nino?
Yeah, we'll. You can send it to me, and we'll give it to the audience after the talks.
Great. I'll post it on my Twitter account, but I'll give them to you as well, and you can just post them on Twitter or Meetup or whatever is more comfortable.
Yeah.
There is, I see one question from Jan. Which way is better to handle exceptions? So I think the option of using sealed classes. I started today actually writing an article about that. So sealed class in Kotlin essentially is an enum. That is very interesting because you can enum each a sealed class. You can define, for example, success and error, and success can contain a generic type of data, and error can contain an exception. And then you can use the keyword is to see if the object that is coming is success or is error. And if it's success, you can directly access without having to do any conversion or any check. You can access the generic type. For instance, something like a JSON response. If it's an error, you can access directly the failure. I think that's a fantastic way to deal with error handling in coroutines, super error safe, and gives you everything that that you want. And okay, that's my topic from Karin. Too much about that.
I think that's it for now. Are there any more questions? I don't think so. That's my topic. Yeah. Okay. Perfect. Then let's go to our next speaker, Enrique. Thank you very much again for joining us. Hope to see you around soon. Thanks a lot. And bye. Now I'd like to introduce the next speaker, who is Karin Monoid. Do I pronounce this correctly, Karin?
Yeah.
So it's not monad.
No, it's just a monoid, sadly. But if I get into the category of the endofunctors, I may become a monad. So whatever.
Okay. Yeah, you told me that you love functional programming and you like to advocate for functional programming and also with Kotlin, but for the good parts. So in my opinion, functional programming is always this light at the horizon, which I always want to follow, which I always want to get to. So for me, this is the perfect way of writing code. But what's the bad part about it? Tell us more about this.
Since today I will be making just an entry-level talk, I won't go into the details of what are the like the worst parts of it. But for example, for the beginners, some parts are made tricky and you have to read a lot of stuff and maybe get a PhD in mathematics. So for example, something like free monad or Clasley just make people scared of all of this. And also a lot of concepts are pretty foreign for the developers that are not quite familiar with the functional programming approach. For example, the concept and the aftermath of functional and pure programming, for example, can we even use logs and random or something? So for beginners, I will say something like this.
Okay. Yeah, just let's quickly jump into the talk. I'd say don't lose too much time right now. I'm very interested to hear about your hands-on session on Kotlin, and yeah, go for it. On Arrow.kt, actually, right? Yeah, Arrow.kt is the library you want to introduce to us.
Yeah. Let me share my screen.
Yes.
1 second, I will hide this annoying thing.
Yeah, because no one knows that we use StreamYard.
Yeah, it's actually also my very first time. So thank you everyone for coming today. My name is Karin. I'm a senior software engineer in the Berlin's company called Delivery Hero. And actually I'm doing backend on Kotlin for our Enterfraud project. And today I want to show you a pretty introductory talk about Arrow. It was like an idea that arose when we had a project like mostly written by Java software engineers and like with Kotlin, which is a slightly better Java, and then we enhanced it. So I hope everyone will find something interesting today. So today we are gonna talk about what exactly is Arrow, what is a non-empty list either, and the scary monad comprehensions. First, let's talk about Arrow. Arrow is a functional extension to the Kotlin standard library. It's actually multiple libraries, starting from the very basic things like the non-empty list, which we'll talk about later, and ending with tools to create compiler plugins like Kotlin Meta and traversing immutable structures, which is Arrow optics. But today we are going mostly for Kotlin Arrow.kt core. So don't be scared. So first, non-empty list. Imagine you have to integrate or create the API as follows. For example, I don't know, you have a shop and the people are buying some items and you want to get a list of the payments that, for example, they paid with a card or something. While every single field in this API is marked as required, can we make the payments themselves empty? While from the software engineering standpoint, it's completely valid thing because like empty list is just a subset of lists and it's totally fine. From the business logic standpoint, it may make no sense because if the customer didn't pay for the item, we will not proceed with the order at all. So we decided to restrict it using non-empty list from the Arrow library. So the idea is really basic. If you pass to the non-empty list constructor function just like nothing, it won't work for you. But if you pass something, it will work completely fine. So sounds easy and not scary at all, isn't it? Okay, let's look into something more scary. It's either. But first, let's take a step back, even like back to Java. So not everything in our code will work perfectly, and we are mostly aware of that. We have in our language some concepts that can help us to operate with some kind of errors or exceptions. For example, if we write a code on Java and we know that some checked exception will arise, we will write something like this: if something wrong, throw something. Then we mark the method signature with a keyword throws and handle it somewhere on the top level, and that's it. Sounds pretty easy. And then on the top level, we will write something like this: try catch, maybe finally. It looks like pretty simple, and there's nothing wrong with that. But sometimes there are APIs that are not really compatible with that approach. For example, Stream API, and sometimes it's like not really convenient to write something explicitly, because we may know that there's an error, but we don't. But because we can know that there will no error or exception or something, but we don't really care, which is a bit tricky. For example, imagine we want to repeat the calling of the function 10 times using this API. So it looks like simple and clean, but to be honest with you, this will not work, because the test fun that we introduced on the previous slides throws a checked exception, and we should handle it somehow. Like, we can just write in this part try catch, but then it makes no sense to introduce the stream-like style. We can also write this try catch somewhere else and wrap it, for example, in a unchecked exception called the method hide exception, and this will work. But the problem is we don't really know on the compile time what exactly it is, what kind of checked exception is that. And then if we want to somehow restore it, we have to write another function that will map the checked exception back to unchecked exception. But yeah, that's kind of inconvenient, because first we have to write this hide exception function for every API, and then unhide exception function we have to like manually map it back. So it looks like not really good. Let's look at Kotlin. In Kotlin, like in many JVM languages, there's no more checked exceptions, which is completely fine. And if we try to rewrite the Java code in Kotlin, it will look neat and simple. Of course, writing it with the function like repeat n times will be better, but whatever. The problem is sometimes we actually want to know that something is wrong and know about error. So let's see what can we do. So if something gets wrong, for example, we can use null. It's like a bit old-fashioned, but nothing wrong with that. So if we succeed, we just return the value that we are expecting. And when something gets wrong, we just say, let's return null. It's like convenient, because like in Kotlin standard library, there are a lot of functions like to int or null to help us with the null checks. But the null is not really expressive, because like we are getting null and what's it about, just something wrong, and what exactly is wrong. Also, it leaves a lot of question marks in your code, so maybe it's not the best solution for everyone. So let's see what alternatives we have. For example, in Kotlin, there's a class called result type. It will return you either your type T or exception. Also, it has some nice functions in the Kotlin standard library, which you can use. For example, you can rewrite try catch without nesting, but chaining. But to be honest, it's not really way too superior to null, because we still don't have really a lot of information on the compile time on the error. What can we do also? In Kotlin, we have such a thing as seal type. If the number of the outcomes is somewhat fixed, we can just write every single one manually. For example, imagine if you want to trade stocks for some price. It will either result in success or something may get wrong. For example, the moon was full and the stock market crashed, or I don't know what is the belief of some unlucky belief in your culture. Or for example, Elon Musk tweeted something and yeah, the prices skyrocketed or dropped dramatically. It's kind of nice, but you can see in theory you can have multiple successes, but most of the time you have only one success and then everything else is error, which leads us to the pattern of either. Either is a type, is a class that is typed with two types. The left one is some kind of error, exception, or whatever, and the right type is the type that you are actually expecting in the successful case. So there's also the mnemonics that the right is right. So on the right, so the right type is actually the type that you want in the positive case. There's also a neighboring type, validated, which looks kind of the same, but they have slightly different use cases. Either is used when you try to validate your data, and on the very first fail, you return that no, we never succeeded, so drop it. Validated, on the other side, is used when you want to validate every single field and collect the information. For example, here the phone in the test data is a string, and with the either we will say no, this user is not valid user, and just drop it. With validated approach, you will collect everything here, but I want to suggest never to validate names and read the great article on of what software engineers are thinking about names and why it is wrong. So just never validate names, honestly. So let's start with something more tricky with monoid comprehensions. But first, let's take a smaller step back. No Java, but still Kotlin. Here, imagine we want to implement our API that we discussed, and we want to validate every single field that we will have. What can we try to do? In Kotlin, we have the concept of contracts, and for example, the function require not null, which will throw an exception if something is not valid. Let's take a look at the signature. You can also write your own contracts, and I think it's a pretty interesting approach, but it's not universal, because sometimes you don't really want to throw anything and you have to come with something else. Let's see. If we don't really want the exception if something in our data is null, we can just use if else, if else, if else. It's pretty verbose and code repetitive, but it works. It works. Let's see if there's something else that we can try. And here we come to monads. Yeah, it's a scary word, but don't worry. you actually, or at least most of you, actually met a monad someday. So I won't go into the details, but most of the important properties are a monad is like some kind of container. It has some function called flat map that will map your data. For example, let me think, a list is a monad, we can transform it, or the either is the monad. So in Java, optional is a monad-like structure, but let's see how can this help us. Monad, since it's like transformable, we can write a chain of different checks, but there is a little help from Arrow library, and let's take a look at it. So with fx, we can actually do the following. If we have multiple checks that will result in a single return type, in our case, this will be either, because check for null, as we defined, is a function that will return either error response or the type T. So we can just list them, and after each function, we just do a bind, which, so to say, will do the following. We will either get our right value and continue to the next line, or we just will get our left value and stop. Which, in my opinion, looks pretty neat, and you can also do that with other monads. So yeah, that's it. I hope like you got an impression of what can be done with Kotlin FX on a very basic level. We, of course, didn't dive into anything like scary, like free monads and even option, but yeah. I hope you can bring something new into your Kotlin code and make it less Java, and maybe take a look on the further structures. Yeah, thank you.
Cool, Karin, thanks. So I'm definitely not afraid of using Arrow. It really made me want to use it. Thanks for this talk. So and as we can see, there's a lot more to all this. Yeah, I'm really looking forward to diving into this. Thanks. Let me quickly check if we have any questions here in the chat. Yeah, Dannan says, well, pretty inspired by either now. Yeah, that's what I thought too. Enrique already mentioned the sealed classes we can use in Kotlin for returning values, either an arrow or a success case, for example. And so this is a great alternative for that, I think. And he says also, thanks, Karin. Pamela Hill says, thanks, Karin. How could you suggest someone that only knows a little about function programming gets into Arrow? How would you suggest someone that only knows a little about function programming to get into Arrow?
Like, it depends what exactly is a little of functional programming. I think while Arrow documentation sometimes just is a little bit non-existent, but for the simple cases, there is like nice docs if you like to read them. Also, they have a really nice sub-channel on the Kotlin Slack, and the people here are really helpful. So I think you can also pick them for the materials.
Okay. I hope this answers the question. It's pretty well documented, and I think, yeah, if you don't know a lot, there's always a lot to get started. Yeah, Fai says also, thank you, Karin, well done. And Robert Henley says, Manning Press has functional programming in Kotlin, which uses Arrow to teach functional programming. Nice.
Oh, that's actually interesting. Never heard of it.
Okay.
Guess I learned something new today.
Yeah. So I guess there are no questions anymore. Yeah. So thanks a lot for your talk again. It was very nice having you here, and I'm sure we'll meet again and have you in our shows again. Thanks a lot.
Thank you.
And thanks also Women Tech Makers again for enabling us here. Bye, Karin. Now, we had a great evening so far, and it all actually kicked off with Nick Skelton, which I asked, don't you want to be part of GDG Nuremberg once? And don't you want to talk on our next event? And so that's actually what the principal idea was, to start this event. And so I'm very happy that Nick is also here tonight for giving his talk. Hey, Nick.
Hey, can you hear me?
Yeah, perfect.
Okay, sweet. Yeah, thanks, man. And thanks a lot to Karin for swapping with me. I really helped me out a lot. It just means I didn't have to rush and stress out. And starting a presentation all stressed is not a great start at all. But I caught actually most of your presentation, Karin. It was awesome. I learned some stuff actually, and actually to answer the last question that person asked about what's a good way to get into functional programming, I reckon a good way is actually with Flow. Flow is kind of like some of the concepts in functional programming are similar in Flow. They're not exactly like Arrow is nice and pure, but yeah, some of those things. I mean, I learned some stuff while listening to your presentation, and I was like, oh, that's something I was going to say in my presentation, so it's cool. Yeah. But yeah, anyway, thanks Nina for having me as well. It's really cool to
yeah, of course. So do you want to dive into directly, or should I introduce you a bit?
I don't know.
Yeah, okay. I tell a few words about Nick.
Okay.
Yeah, Nick is a Google developer expert, the second tonight for Firebase, and as I know from personal experience, also very good and motivated Android developer.
Excellent.
Yeah. And well, I did some more digging actually in the internet, and I found out that you were an ecological farmer in Australia before becoming a developer. Is that true?
An ecological farmer.
I completely made it up. So
I mean, actually, I've worked on farms before, but I was like,
oh, really?
I don't know if that really counts.
No, I just made it completely up. So
I mean, I did for a little while. So yeah.
Yeah, but tell us something about yourself. Maybe introduce yourself a bit. You can do it the best, I think.
It's going to be all downhill after that nice introduction, but yeah, sure, man. So I'm from Australia, but I live in Munich, and I lived here for almost 6 years now. What else? I've been at GDE for a while as well, and I've been a mobile developer for like my whole career, basically, which is, well, I'm old. Yeah, but I sort of specialize in Android.
Don't say that so often. That means that I'm also old.
Yeah, we're old, man. It's cool to be old. I still can't grow a beard, though. Thanks for noticing. Who is that? Dan, you noticed that I have a beard? Yeah. I'm still going through puberty, and I'm almost 40. So it's a strange world. But yeah, man. What else? I've been working with Kotlin for a long time, and I mean, actually, I worked with Java for a really long time, and like Kotlin came along and just. I mean, I've been working with Java on Android for a long time, and Kotlin just opened my world. You know, like if you're an Android developer and you're listening, you really understand how much of a godsend Kotlin was. And then RX Java as well was something that I got pretty deep into a few years ago. And now Flow's come along, and I'm just loving it. I'm having a great time learning about it, and yeah, that's kind of what my presentation is about. A little bit about how I learned Flow. I mean, I still am learning Flow, but yeah, that's about it. I'd love to just dive straight into, well, some slides, sort of some background about what I'm going to show you and why. But I'll try and keep this as codey as possible, if that's going to work with my new computer. Let's see.
Sounds great. So let's start.
Let's rock and roll. All right.
Yeah.
Let me swap over to some slides just so that you guys can follow along. So, Kotlin Flow, A New Hope, a long time ago in a galaxy far, far away. So you can tell, obviously, this is something about Star Wars. It wouldn't be a nerd fest without some Star Wars in it. But
we don't see your slides right now.
I do have to share my screen, of course. I've only been working remote for like 3 years. Yes, please share my entire screen. All right, see me now? Yeah, okay.
Yeah.
Yeehaw.
Wow.
All right, there we go. So a few years ago, or it's a while back now, I was working in a project in a team that was pretty heavy on RX Java, and we were pretty autonomous as well. We had like we were allowed to sort of hire whoever we deemed was a good fit for our team. And to do that, we decided to give them a homework task, and we kind of put our heads together and actually it's a topic that's really quite difficult to get right, recruitment. But anyway, for one reason or another, we decided to give our applicants a homework assignment. And what we wanted to do was, we can't just give them the source code to our app and get them to work on that source code somehow. Even though that would be ideal, it kind of breaks, privacy problems. We can't just give our source code out to people who aren't under contract. But also it's kind of, people don't just work for free, when they're applying for a job. So that's kind of bad as well. So what we came up with was, let's try and make a small app that kind of uses the same tools and uses the same patterns, the same code style. It's kind of like a small version of our real app, but it kind of just is about Star Wars. And so, yeah, we kind of made a little repository in GitHub, and we would give people, applicants, the repo and say, here's some bugs to fix, here's a feature that we want to put in there. And you can sort of just pick and choose from the backlog, let's say, and go for it. And what I did recently when Flow came out was I kind of resurrected this repository and converted it all from RX Java into Flow, just as a way of exploring Flow. So one of the greatest resources is all about giving you the sort of a shortcut to the same goal as what I had. So what I did was I read a lot about streams in Kotlin by this guy. There's heaps and heaps of articles on the internet about all sorts of stuff in development, but I really can't recommend enough to go sort of to the more rich content, not just about like, here's how you do this and here's how you do that, but why. So why does Flow look like that? Why is Flow being designed like this? Why is Flow better or worse, or how do you compare it with RX Java, for example? What's it trying to solve? And this guy here, Roman, he's kind of like, he got promoted actually recently in JetBrains, but he was and maybe still is the guy who is leading the charge with Flow and coroutines and stuff like that. So keep an eye on this guy, digest all of his articles, and you'll really understand a lot about where Flow is coming from, what it's trying to solve. Right, let's get into the app itself. Looks amazing, right? Yeah, it's just a list of characters from Star Wars and then a details screen. Pretty straightforward. There's really like, it's not going for the Design of the Year award, but it's more about the code. What it does is it hits a free API. So there's a free API in the cloud that you can use called the Star Wars API. When I first did this presentation, it's a free API, so it's not exactly mission critical, and the API went down. So I since then I've built a mock service, mock API, which I can switch on if it suddenly fails on me. Anyway, it's I chose it because it's pretty straightforward. It's very easy to understand. It's more or less well presented, and you can quickly browse all the data that they serve up. Just a nice, RESTful, free API that's out there. So the first task, how well can you copy and paste? Now, a lot of people, when I'm not just talking to myself in my room and I'm actually presenting in front of actual people, might laugh when I say that. But actually, I kind of mean that in ounce, like seriously. It's funny because when you're a junior developer, you do a lot of copying and pasting, and actually it's a skill. You learn how to copy some code and like paste it here, and then make it work with your code and check that it works and blah blah blah. And that's kind of like the first step you take when you're a junior or beginning programming. Okay, sometimes I still do that too now, but but anyway, it's a skill that you need to learn, right? But actually, as you go along and you get more experience and more confidence, and you start to call yourself a senior developer, and like now me, I'm a contractor, so I move from place to place every few years. You gather this kind of like experience. And when you go to a new company, you really want to push your experiences onto people, right? And so instead of copying and pasting code, you're kind of trying to push people to do things your way instead. And so the second sort of level of copying and pasting is learning how to adapt to a code base that's already there, right? And so actually, while this task looks very simple, actually, what we were also looking at is how well someone can read our code style and adapt to it, rather than just like come in and refactor and do it their own way. How well can they read our code and extend it, build on top of it. So anyway, it's pretty straightforward. It's just like we want to add some details to the detail page. We want to have a look at their body mass index of this character because we have the weight and the height. So it kind of forces the applicant to put in like a vertical line. They need to understand how the view works, how the view model works, how the like service works, how the DTO classes work or whatever, right? And this is kind of the end result. Okay, good. You can see that there's the height and mass. So we have that information, right? The nice animation. Okay, enough of this. Let's go into some code. Now, are you guys able to see this? I did some tests. So maybe Nina, you can tell me if that's like visible, or whether I should scale it up a bit. Maybe.
Yeah, I think it's a bit small because the quality is not that good.
Rightio. Let me scale this up. Let's see if this works. Still a little bit small. Let's go crazy. Is that all right? Still crap?
To be honest, yes.
That's cool. It's cool. I want you to be honest. What about now?
Yeah, looks good.
Okay. Yeah. Sorry, I recently just got built and started using an Ubuntu computer. Built up a beast of a computer and migrated from Mac, and I'm still wrestling with some of the gremlins. Okay. The problem with this is I can't really show you the structure of the app, but that's okay. Let's take a look. So, okay, I'm not going to go too deep into how the service is created, but I will focus mostly on this person view model. So the person view model is the details view model, and this is kind of what it looks like. It's the model of the view, so you can see all the different properties that we want to show eventually on our view, right? Lots of people do this different ways. You can put it all into a state and send the whole state up, whatever. Put it in a sealed class, blah blah blah. Everything's cool. Lots of different ways, but it's just nice to have like a full overview of exactly what your view looks like, right? So view model. You can see that these are all flows, right? Which is a bit strange, maybe at first glance, because most people would be used to seeing something like live data here. As time went on, I did this repository. I think I started it maybe a year ago now. Flows kind of come forward in leaps and bounds, and I slowly took live data away completely and started to put things directly into the fragment itself, right? So we have these kind of bindings here, which is makes our fragment super thin. There's not really much happening. It's just like, this is the flow, put that flow into this text view, done, right? And if we go deeper and have a look into these little extension properties here, you can see that each property, each time the fragment binds to our view model, we're launching a little mini coroutine inside the lifecycle scope of our fragment, right? And doing a little collect, and then, yeah, adding it into the text view, for example. So it's not too complicated here. I mean, there's lots of sort of things to understand, about lifecycle scopes and that kind of thing. But in general, what we're doing is terminating our flows. So terminating our flows in the fragments here by just taking a text view and assigning a string to it, for example. Yeah, so it's important to know that there's a coroutine for each property that's being bound here. So let's have a look at task 1. Right, so task 1 is to go away and get a person. Right, Star Wars service allows us to take a person ID and go and get that person. Right, and we do some already cool stuff here, right? Similar to what Karen was saying with monads and stuff. We're starting to get into functional programming just by doing a simple map. This is already getting functional. And what are we doing here? Getting a person. This returns us a flow. Right, so we get a flow with a result of person. Right, again, doing what Karen said and wrapping things in a burrito, and then deciding what to do with that. Right, and okay, we're not doing anything well here. That was actually one of the other tasks, was to implement some error handling. We're actually doing nothing, which is naughty. But if we get a success, then we send back a person. So we have this kind of private flow here, which is providing the rest of the view model with a person. Right, and a person, just so that you can see, is again just a serializable representation of the API that we were talking about before. Let's go back. Now, this is what we had already, so this is already existing. We have this person flow, and we're just going to extract the name out of it and give that to our fragment. Height, birthday, these are all flows that are just sucking some information out of this person. And it's really nice that, because what you can sort of see here is that we are quite literally flowing information, right? Kind of reducing it. So we need a name, so we go to the person, and for the person we go to the service, and that's it, right? It's just like it feels to me after a while like a flow, flowing in like this, and then flowing in to the height, flowing in to the birthday. So we need the BMI, right? So let's just run this. Oh man, don't know how to actually. Oh yeah, it's easy enough. Let's run it so you can see what this looks like. Oh yeah, here we go. Now we're using the actual API here, which is awesome. It's working. Let's grab old Darth, and voila, up comes his details. Cool. Now we need the BMI, right? Now, like I said, not really super interested in how we construct the BMI. We can go and have a look at that. It's not really flowy. It's kind of interesting. It's still good to know that people are using, like, you know, Kotlin classes, Kotlin extension functions, and, you know, using big decimal and setting scale and doing fancy stuff like that. That's cool. But what we're more interested in is that they're following the same pattern as we have here. That's kind of interesting. Now there's one more thing. I just finished playing Doom. I don't know if any of you guys have ever played Doom. I played it when I was a kid a lot, and then I recently got a piece of a computer and decided to play a game again. And I played Doom, and in Doom you go through all these like mazes and levels and stuff, and as you go there's secrets, and these are like sort of pointless things. Actually, you find secrets and it's just like a little toy or something, and I don't know, makes you feel good. But there's kind of a secret that if you have used RxJava or flows a lot already, you'll kind of notice something here already that is bad, right? I don't know if I can actually show you this. I might just have to bounce out of this for a second to show you what the problem is here. Sure if you can see that. Okay, maybe you can't see that, so I'll just highlight it. What's happening here is when we go into this person page, right? We go and see Luke Skywalker, for example. You can see here that we're actually making 1, 2, 3 calls to the backend, right? So there's actually 3 requests that are exactly the same that are going to the backend. 1 for name, 1 for height, 1 for birthday. And if we run this again, you can see that now there's 4, right? Get person, get person, get person, get person. This is the ID, and this is the counter. We've called the backend 4 times to get 4 pieces of information. And that's bad, right? We don't want to be making 4 calls for every piece of information that we want to show on the screen. What that means is this flow is what they call cold, right? So every time someone asks for person, it's going to create a new flow, right? Unless we do, this. So, okay, you can't see that. Let's put that back in. Unless you put in an operator that allows you to share it, right, within the scope of the view model. So what that means now is that every time we ask for a person, the first guy, if it's name, who gets bound first, he's going to ask for the person, and then these guys are going to wait until the first person comes back, and then they're going to share that flow. And that's kind of a secret, just like in do. That is that. Let's go back to some slides. Flat map. Now this is where I was like doing fist pumps during Karen's speech, because flat map is, I never knew that flat map is a monad. That's cool. You know, like there's lots of new terms in functional programming that are kind of scary. But now that I know that a monad is a flat map, I am less scared to try out some functional programming. That's cool. But anyway, still, even so, like flat map is one of those operators that also kind of separates the people who have done any sort of reactive programming with RX or Flow from the people who have just sort of maybe seen it, and maybe they've started up a new thread with it or something like that. Understanding flat map is a bit of a paradigm shift for most object-oriented programmers. And so the next task kind of was designed to separate those people out. Not that it's a bad thing that you don't know it, it's just good to know, right? And how to describe a flat map. Like a flat map is really, it took me a long time to sort of grok it, like what is it? And this is actually a really cool way of describing it. I think that would have helped me a lot, right? So the task here is to add some more details about the character's home planet to the screen. And now each detail screen requires 2 calls. We need to go and get the person, and then we need to go and get that person's planet, right? And just to show you what that looks like from the API data, here we have Luke and all his information, and you can see that there's a link there, kind of like a foreign key in SQL, that allows you to go and get Luke's home world, right? And I'm not sure where the slides are up to. Okay, yeah, but with that information now, we can get Darth Vader, or like we can get the character details, and then for the next step, we can show the person's planet of birth, right? So it's kind of like 2 steps. And then I'm just going to sort of, because we're short on time, I'm going to do the 3rd task at the same time, because it's kind of in the same like topic. And we want to go and get the films too, right? So the films are also a part of Luke's data structure. The only difference is that there's many films, not just one. So we want to go and get a whole bunch of films, and that's kind of important. So it's really important to understand how the data looks like, so that we can translate that into some sort of monad. And then task 3 is to do with the films, right? So we want to also add a list of films, right? So comma separated films to the screen. Code. Thank you for that reminder. Let's go and have a look at task 2 first, and have a look at flat map. So in task 2, and you can see that I just have a little DI thing here to switch them up. You can see here that I've created some state, right? And this is also something that I love about functional programming, right? It's really tight. You know, there's no. It really opened my eyes to the fact that a lot of the bugs in my life that I've been fixing have all been related to state, right? I put a variable here, I put a var there. You know, maybe I have a repository and I keep like a Boolean flag there somewhere and turn it on, turn it off. All those things like add complexity to your code, and this removes it, right? So what we're doing here is very similar to what we did before, right? Before we had this like central person, right? That we were taking as our like main source of data, right? Here, person. This is the main like sort of source of information, and all this stuff is just bindings, right? Or reducing. We're taking things out of here and putting them in, you know, formatting them or doing whatever. But everything that we're interested in is contained within this person. It's the same concept over here, except we have a person and a planet now. So all we do is wrap them in a state, and now everything flows out of there instead, right? So now we have a person that flows from our state, and then the person flows into our name, height, birthday, BMI. Right, we have a planet too, and that flows also from our state, and that flows into da-da-da-da-da. See what I mean? It's kind of like little tentacles sprouting out, you know, or like a river with lots of different tributaries, you know. It's beautiful. So how do we get this information though? Right, we have a person and a planet. They start, they're both null, right? And this is obviously very simplified. There's no errors, for example. But it's good just for illustration purposes. So what do? We get a person. And once we have the person, we can convert that into a state, right? And that's exactly what flatmap does, right? It says every time we get a person, and you know, in this, every time we call person, we're only going to get one, right? There's not going to be like multiple person data structures coming back from here. It's just going to be one, but it could be more in theory. So every time we get a person, we're going to convert that into another flow, right? We're going to go and get the planet, for example, if it's a success. If it's a failure, then we're going to just give like a sort of a dummy flow, right? But if not, then we're going to go and get the planet as well, right? And so, yeah, you can see here that the planet, this get planet method takes the person, right? So we need the person if we're going to go and get the planet, because the person has the planet ID, as you can see here. So we go and get the person, and if that's a success, then we go and get the planet. Once we have the planet, and it's also a success, then we can fill our state. And here you can see we're doing something semi interesting. We're just putting a null in for the planet. We already have the person, that's cool. And the planet request failed, but that's, so we're just going to put a null there instead. So you can see that's kind of already separating, it's kind of like the first, I don't know, for me, that was one of the first sort of concepts of reactive programming to understand. So it's worth, if you're not really like super clear on what flatmap does, it's worth spending some time learning, you know, like reading the documentation, doing some examples or whatever, because that's one of the really basic concepts I find anyway in that is kind of difficult to understand as a beginner. Right, that's the first. task done, right? And I mean, this stuff here is again just yeah, pretty trivial. I'm not going into that. The third task is where I had the most fun though. This is really, oh, sorry, I'll show you that working first quickly. Come on, buddy, don't let me down. There you go, boom. So now we've got some planet details as well. Yeah, this is the third and most complex task because I really wanted to get it right. I wanted to do something really cool here and I didn't know how to do it. And so this looks really daunting. And it is, it's very complex, but I'll take you through it. Before I do though, I just wanted to say, if you see something here that could be better, let me know. Hey, like I just noticed, for example, that state flow, for example, I was using a shared flow here before because state flow wasn't released yet. And yeah, I can't remember what it was, but after the first presentation, somebody also pointed something out, and yeah, it's cool. Like I really would love to know if there's better ways of doing it. This for example, trigger. This is this refresh. I use this to create a refresh, and it's not really my favorite thing in the world. But I don't know how to do it in a better way, cleaner way. So yeah, let's start from the top. So you can see here our state is similar. It's a little bit, it's got a little bit more now. We have a person, a planet, and I tried to do some error handling and some loading as well, right? This can also be done with sealed classes. It's also totally valid. I didn't go for that. That's half an hour. Nino, just feel free to give me a warning or whatever, man, if I'm taking too long. Yeah, you can also do this with sealed classes, totally valid. I find that sealed classes get super complicated and very verbose quite quickly. But in some cases, and in a lot of cases, it makes a lot of sense. But in general, I try to keep it as simple as possible if I can. Yeah, so that's what our state looks like. So you can see here that I'm not sending any models into my fragment, only strings and booleans and sort of primitive types in general, if I can. But I'm not sending person or planet. The fragment knows nothing about them. It doesn't need to. And films, I'm going to reduce down to a string, like the task said. I want to have something like, you know, Return of the Jedi, 1980, comma, blah 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 blah, like this, you know. And so I want a string here rather than you know, a list of films. A list of films could also work, I guess. Right, let's have a look at what this looks like. It's good to just have a quick look to see, because what we're going to do is kind of make a nice user experience out of all of this crazy stuff. So this is what it looks like now. Boom, up we got the main guy, and you can see, boom, we got the planet of birth came back pretty quickly, and you can see that now we're slowly getting all the films that Darth Vader was in. Right? Is it finished? I don't know. How do I know that it's even finished? How do I know that this is still loading? Right? I looked at that and went, I want that to be better. Right? What can I do to make that better? And got into some interesting stuff with flow. So in RxJava, there's really just flat map, and then you can add some operators to do the cool things and whatever that concat do. But actually, in flow, it forces you to make a choice, right? You can see that the flat map, just normal flat map, it's crossed out, and it's saying don't use that. It's forcing you to use one of these, right? And actually, I just literally released an article today on on why they do this, right? Why they force you to do, why they force you to make a choice rather than just letting you choose the easy one. So go check that out. It's to do with concurrency and context and stuff like that. But let's have a little play with these to see what they do, right? So concat, a great piece of advice is to just look at the documentation, right? There's literally like less than 10 lines here. And the JetBrains guys, I love them. They have brought back restored my faith in documentation, because this is super useful. You know, you can look at this and it's actually useful information. It's not just like flat map concat. This is a method that concats a map and takes a suspend value and turns it back into a float. It's like I can read all that from reading the method, right? Now this tells you exactly what it does and why, right? Sometimes it even gives you like diagrams and stuff. It's really cool, right? So let's have a look at what the difference is between concat and some of the other ones. But I'm not going to just tell you what they are, because you can read the documentation yourself. What I'm going to do is show you. Okay, so let's have a look at the difference. So when we go into have a look at Darth Vader, you can see that, boom, he comes up first. We got the person. And the birth and the first film came back pretty quickly. And now you can see that what's happening is the films are being retrieved one after the other. So we go and get the first one, the second one, the third one, then the fourth one, right? But concat means that we're waiting, right? This will go and get this film. When it's finished, then it will continue and we'll go into the next one, right? So these film IDs is just a list of integers. And we're taking the first one, we go and get the film. When it's finished, then we continue the flow, right? Watch what happens when I change this to merge. Prepare for your world to be rocked. Same thing. Whoa. What just happened there? Did I just suddenly get fiber optic connection, or did the merge do something amazing? The merge did something amazing. What happens here is it allows all of these IDs. So in this case, we have 4, right? It allows all of these to happen concurrently, right? So it goes and gets all 4 films at the same time, more or less, right? It does it in the background with threads, whatever. But merge means it doesn't really matter what order this comes back in, right? So let's say we have a set of IDs here, 1, 4, 7, 2. What we're saying here is we don't care. If 4 comes back first before 1, that's cool. We don't care. Send it. If 7 comes back first, send it. If 1 comes back last, that's okay too. The order here doesn't matter. What matters is that they all happen at the same time, right? That's really cool, but still, what I'll do is just quickly switch over to not use the network, because with my other one, with my mock, I have a bit more of a delay in there, so it's a little more sort of obvious. You can see what's happening a little bit quicker, right? So we actually do have a loading screen in there, right? And things come back a little bit slower. I've got my I've got my phone in presentation mode. Yeah, but you can see that there was a loading thing there, right? Let's just go back and do it again. Something went wrong with my mock data here. Loading, that's cool. Boom, 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 boom. Okay, but still don't really know that it's finished, right? There's nothing that tells me that there's still more happening. So I was like, I can do better, right? And that's when I started to get into this crazy stuff here, right? Scan, whoa, and you know, running reducers and like mutable maps and stuff. I went a bit crazy, right? But the result is really cool. So check it out. So you can see that these do the same thing. All they're just doing is returning a flow of string, right? And what I'm doing is basically building this string. As the results come back, I'm using running reduce and scan to, yeah, literally do that. Reduce each emission that I get from this flow. I start to build this string as we go. So let's have a look at this, right? But actually, I'm still using concat here. So I've kind of changed up what I'm doing, but I'm still using concat. So let's see what happens here. My lack of shortcut key usage is probably driving some people up the wall. But all right, cool. Now we have a loading. All right, and we still know that something else is loading, right? That's a little bit better, isn't it? But I got to this point and I'm like, yeah, man, come on. Like, you know, by the time we've gone and got Luke Skywalker, right? I know how many films he has, right? Because of the API. Remember the API? We have a list of IDs that we get. So actually, I know how many films there are. So why can't I just like show that somehow, right? Show that here that how many films there are, and then slowly fill them in as we go, right? And that's what merge also helped me with, right? Check this out. Yeah, I mean, okay, it looks totally ugly, right? It's totally, you know, you never do something like that in a prod app, right? But you could do something creative with that, you know. Maybe you have like a little glimmering, you know, it's like shimmering or something like that, and then boom, it comes up, you know. There's lots of things that you could do with the UI to make that really nice. Yeah, let's just look at it again. I have like a random thing that gives me an error if you know, if it's divisible by 3 or something like that. Yeah. Super fast, super cool UI, I think. Yeah, so I'm totally over time, so I won't go into too much more code. But yeah, just some last thoughts, which I've edited since the last one. There's, yeah, live data, RxJava, and Flow. They all interoperate with each other because they all follow the same manifesto and actually the same interface, right? So it's super easy to migrate between them. I mean, in theory, right? It's still not amazingly perfect, but actually I have a personal project where I've kind of built a interface around like the ins and outs of a RxJava kind of state machine, and it works really well. So don't be afraid of migration. It's built into all of these live data, RxJava, and Flow. Testing, I just started using Turbine from Square, and it's actually the only thing that I can find that actually works for testing flows, like in unit tests. Previously, I was converting everything to live data and testing it like that, but Turbine does a really good job with that. And there's tests in this project if you want to get some examples on how to do that. And I will be adding more in the next few weeks. Exception handling, same as coroutines. Try not to use exceptions. There's a great article by Roman on exception handling with coroutines and flows. I really suggest you read that. Yeah, here's some useful links if you feel like taking a screenshot. And that's it. Last thing is, if you have questions and the question is in German, also don't be afraid of asking. I can speak German. I can understand it much better though. So, and if you're in like somewhere else in the world, right? Also ask in that language because we have Google Translate. But yeah, thanks a lot, and may the force be with you.
Hey, thanks, Nick. Yeah, great talk. A lot of insight in how we can use Flow, and I will definitely use it a lot more right now. I guess we don't have so much questions, though.
I bored everyone to death. Yeah.
No, I don't think so. I had one question. I sent it from my
man.
personal phone, but it wasn't not synced with the chat somehow. When using flow map for every field, what you did in the beginning, when assigning it to text fields, how does it compare performance-wise to a classical approach when you get the whole object at once and then not map every value, but use a getter, for example?
Yeah, I mean, it's a good question, and actually, I can answer it with the sort of, again, with the fundamentals behind coroutines. So, coroutines, you can see that I launch a coroutine for every single one, right? And that's exactly the point of coroutines, right? They're like they are super lightweight threads, basically, right? So they, when coroutines first came out, and even now, there's heaps of posts and talks by the JetBrains guys about performance tests that they do, where they're just like, look at this, just like create like a billion coroutines, and to just sort of see, compare it to threading or something. So actually, creating 1 or 10 is just, it doesn't matter. Like performance-wise, it's just like, it's so minute that it's not perceptible at all, in my opinion. I mean, it's actually leveraging the benefits of coroutines. Yeah.
Yeah, cool. We have another question.
Yeah.
Danan says, is it a bad pattern if you collect the flow data back into live data?
No. In fact, that's what I've been doing for a really long time. And only in this pilot project am I not doing that. So I've just sort of, I don't know, it's been a while. I can't remember when I did it, but I did it in this private project, this sort of test project to play with that. But in most places where I've worked and even older private projects, like I'll use Flow or RxJava all the way up to the view model, and then where you see all those like name and date of birth and all that sort of stuff, and it does like map. At the end, you would see this little extra operator called as live data, right? And that just converts it into live data. Again, like performance is just, yeah, it's not a big deal. Like it's much more. There's so many other things that are happening in your app that are worth focusing on than that. In my experience, like converting it to a live data is fine, totally fine. Yeah. I mean, you don't need to anymore, but yeah,
You can. Yeah, thanks. I don't see any more questions, just compliments. Nice talk, Nick. Excellent talk and resources, Nick. Awesome talk. Thanks a lot. And so on. So I guess we didn't bore people to death. I guess they liked it. All that I have to do is to thank you again, because I also thought it was a great talk. I will definitely check out the GitHub repo and go through the sources. And if it's possible, I'd also like to thank Denise again. Is Denise here?
Yeah. I'm here.
Because we shouldn't forget that also women tech makers participated here and made this possible, the whole thing. So yeah, thanks a lot, Denise. You were a great help and helped us a lot also by with organizing the whole event.
Yeah,
is there anything you would like to share?
No, I really, yeah, so what I say at the beginning, so everybody took something from the talk, and I really liked Nick's analysis of the UX, that is my field, so that was very nice. And yeah, so the chat was also very active and very friendly, so I really enjoyed this event. And so just 3 tasks for the people that follow Women Tech Makers Nuremberg and UDG Nuremberg, that keep healthy and that join us next time all together. Yeah, that's it.
Thank you. Good ending.
Thanks again for having me, man. Yeah, I really had fun as usual.
Yeah, cool. All right, people. Then I say we wrap it up. Have a good evening, a good weekend, wherever you are. Stay safe and healthy.
Yeah.
Bye.
See you guys.
See you.
See you.